Okay, so this is the hot air oven method of sterilization. So at higher temperature, sometimes the wrapping paper may burn off, and as you see, probably sometimes some high temperature was set and some burning was there. So to be the safe position, we need to set it at 160 degree, and we have to maintain 2 hours time once the inside temperature is 160. Please mind it, not from the beginning of this process. Once the temperature reaches 160, then only we have to count the time for 2 hours and the item will get sterilized. So thereby we can sterilize all glasswares. We can sterilize cotton swab attached to wooden stick or bamboo stick, not in plastic. No plastic wares we can put it in the hot air oven. Sands and then oils, we can even the paper, sometimes we need some sterile paper dishes, and then those paper dishes are sterilized by hot air oven. Okay, so please note it, the time 160 degrees centigrade for 2 hours is the method of sterilization. Then coming to the moist heat type of sterilization, the first one is the dry heat, and here it is the moist heat type of sterilization. And there comes the machine autoclave. Autoclave, as you know, in Louis Pasteur, he designed this particular autoclave, and this is as simple as that of the pressure cooker that we are using for cooking purpose. So also it is called as steam under pressure. Steam under pressure. Why this word we use it? As all of us we know, like when you boil water, the water should reach 100 degrees centigrade. Under no circumstances the water temperature, boiling water temperature, exceed 100 degrees centigrade. And that 100 degrees centigrade we attain only in the sea level, not in the place of Brucus Murray is somewhere at 13,000 feet altitude, higher than the sea level, I guess. Brucus?
Yes, sir.
Yeah, people sitting in Bombdila is 14,000 feet again. So there, if he try to boil water, he will never attain 100 degrees centigrade in an open container. His temperature will be lesser than 100 degrees because it is straightway related to the atmospheric pressure. Once the altitude increases, the pressure decreases, and the boiling temperature also decreases. So here in the autoclaving process, how it works is that we increase the pressure, and in the pressure cooker, when you put the lid and then put in the flame, the steam will rise by boiling water, but the steam cannot escape because you have locked it. So when the steam cannot escape inside the pressure cooker, the pressure increases. As the pressure increases, the temperature also increases. That is the process how our pressure cooker works. And the same principle he applied, and he designed a equipment called as autoclave, and the process is called as the autoclaving. And out of his research, what he found that until and unless we attain the temperature 121 degrees centigrade, and if we cannot maintain at this temperature for 15 minutes, the resistance spore will not get killed. So as a result, he set the temperature that autoclaving is a process, is a steam under pressure, where we heat up the item in a moist environment up to 121 degrees centigrade, and we maintain that temperature for 15 minutes, minimum of 15 minutes. That will make sure that all organisms, including the most resistant spore, will get killed, and we will get the item as sterile. Think about the distilled water, think about the buffer, think about some bacteriological media. You prepare it, and during the preparation from the fungal spore or the bacteria which already present in the water or the utensils, or maybe from our hand during handling, they will fall into the media. We can kill them by autoclaving process. So it is called as the steam under pressure. So in this table, it is showing like once the temperature, the pressure increases, the temperature will increase. If the pressure is 10 pound pressure, then the temperature is 110 degrees centigrade. But when it reaches 15 pound pressure, then the temperature is 121 degrees centigrade. And it is the international norms that all laboratories follow. We set the equipment at 15 pound pressure. And once the pressure will attain 15 pounds, then we know that the inside temperature is 121 degrees centigrade. So once the indicator in the autoclave machine indicates 15 pound pressure, then we start counting for 15 minutes, not from the beginning. Okay, mind it, both the case. So when it attain the 15 pound pressure, then we start counting for 15 minutes. We maintain this pressure for 15 minutes, and we know that at that time the inside temperature is 121 degrees centigrade. So if you can maintain for 15 minutes, whatever the solution, buffer, and the media chemicals that you put it, they will become sterile. And this is an absolute term, means total removal. Okay. So no other process now just to try to correlate, like sterilization of our hand. Is it possible to heat up our hand like surface in the hot air oven and the autoclave? So absolutely not. That's why this hand surface cleaning is called disinfection, not sterilization. Please mind it. Okay. Think about a room. We cannot sterilize a room. How it is possible? We cannot put a room inside an autoclave or a hot air oven. No, it's not, absolutely not possible. So what we can do, we can disinfect a room. We can disinfect a table surface. We can disinfect an equipment, but not sterilize. Okay, please remember. So internationally recognized method is the 15 pound pressure for 15 minutes, and temperature is 121 degrees centigrade. That we can sterilize the media and chemicals. And all the times when we prepare the bacteriological media, we sterilize them by autoclaving process. Okay. So nowadays there is some modified plastics like polypropylene PP and polypropylene copolymers. Items are also available which can withstand the temperature of 121 degrees centigrade. So only the autoclavable plasticwares we can sterilize by autoclaving, not all. Most of our household plastic containers cannot withstand the temperature, and then we cannot sterilize those plastic items. Only the autoclavable plastic only we can sterilize by autoclaving. Okay, so these are the two processes, hot air oven and autoclaving, which are most commonly used in microbiology laboratory for sterilization purpose. Okay, and let me remind you, these are called sterilization process. So let us see a little bit about these are the equipments, 3 autoclaves that we are running in our lab on a regular basis. So one is meant for discarding the waste. For example, if we initiate some culture work, and once the culture work is finished, then we just disinfect, sterilize it by this equipment, and the other 2 we use it for normal routine sterilization process. So if you can see a schematic diagram, how it works is very simple, just like a pressure cooker. At the bottom, it is having usually these machines are made up of very thick wall and high strength metal container, because they have to withstand the high pressure. So at the bottom, heating element is fitted here, and above it we had a sorted platform where we can keep our media bottles and whatever you want to sterilize, you can put it here. And then we switch on it, and then gradually the water, and sufficient water we have to put it inside it so that it doesn't dry off, and then the steam will rise, but steam cannot escape. So we have to close the lid very tightly. If we just go through it, these are the lid, very tightly we have to fit the lid. And then once the steam will rise, steam cannot escape. So when the steam cannot escape, the steam will go on accumulating, the pressure inside will increase. Once the pressure will increase, temperature will also increase. Got it? So when the pressure reaches around 15-pound pressure, which is indicated by this pressure knob here, and in this machine here, these are pressure indicator. So when it reaches 15-pound pressure, then we start counting the time, and for 15 minutes. There are certain adjustment knobs like this and this and this here, through which we can maintain this pressure at a constant place for 15 minutes. So after completion of the 15 minutes, we switch on and then switch off the machine, and gradually we allow it to cool down. So thereby, within this 15 minutes of 121 degrees centigrade, we can sterilize the item. So this is called as the autoclaving process. So some safety devices are also present here. Okay, this particular model, we call it as a vertical autoclave because its orientation is in a vertical position. So there is another what we call as a horizontal autoclave. So in public health department, they are having a horizontal. We don't have horizontal in our lab. So only the orientation is different, which is attached with some already preheated steam chamber, and we can release the steam and we can put the items here. So once the pressure attains 121 degrees centigrade, we can maintain it for 15 minutes, and that will serve the purpose of autoclaving. So these are the two most common methods that we use it for in a microbiological work. One is the dry heat, another is the moist heat type of sterilization. Okay, so most of the times we'll be doing this technique. Whenever we prepare any media, then we sterilize them by autoclaving, and then glasswares we can prepare it by hot air oven method of sterilization. Then comes to another what we call as the high powerful radiation energy that we can use it for sterilizations, and as well as both the method can be used for sterilization and disinfection, where the ultraviolet radiation UV lamps are fitted to some of the equipment, and when you switch on this UV lamp, then what will happen, this UV ray will kill the organism. You know, this UV ultraviolet radiation, they mostly cause damages to the DNA material. So once the DNA material get damaged, that organism is unable to replicate and as such get killed. But sometimes these ultraviolet radiations are not sufficient to kill the resistant spore. So in that case, the ultraviolet radiation, mostly we apply it for killing the vegetative form of the bacteria. But the gamma radiations are much powerful than the ultraviolet radiation. So this gamma radiation in the form of some device, what we call as the gamma chamber, like this with gamma chambers, where we can put out the surgical items, we can put up the plastic syringes. Nowadays, the disposable syringes that we are using in the regular basis for injection purpose, all are sterilized by gamma ray sterilizations. So gamma rays are much powerful, can kill all type of organism, including the resistant spore. So as such, these are ionic radiation. So all the radiations we can divide into non-ionizing and ionizing radiation. So UV and infrareds are non-ionizing, whereas the X-ray, gamma ray, cosmic rays are ionizing radiation. So out of which the gamma rays are used for sterilization purpose. Most of the time, the surgical equipment, gloves, and any other things we can use it. So UV rays, as I think I have shown it here. Okay, this is a laminar flow. So most of the laminar flow workstations where we can get a very clean air system, the UV lamps are fitted to inside of this chamber. And before starting the work, we switch on the UV and close the lid, and we usually do not remain in this area. As you know, the UV rays are equally effective and toxic for our body. If it falls for long duration in your cornea, the cornea may get damaged. So likewise, it is very harmful for our body. So the microorganisms, this can be killed or inactivated by using this UV light fitted to this kind of small areas. Even like some of the hospitals and the operation theaters are disinfected by UV radiation. Remember, small cubicles, rooms can be again disinfected by ultraviolet light. So gamma radiation can assure your complete sterilization, whereas ultraviolet radiation is mostly can cause disinfection of an area or a room or a surface. So these are some of the physical method of sterilization. As the different ray system, their penetrating pulse are shown it here. The gamma rays is the most penetrable form of rays, and that can disinfect the items, that can sterilize the items, and the sterile item we can use it. So these are some of the physical method of sterilizations. Now, if I shortly recollect things like what basically happened in the dry heat type of sterilization, how the organism get killed, everyone can say once it heated, the temperature increases, that all the moisture present inside the bacteria or the spores will evaporate. Of course, the spores contain very less amount, but everything will dry off. And after that, the temperature, when it goes up to 160 degrees centigrade, all the surface proteins and structures will destroy virtually. As a result, the organisms get killed. Okay, in moisty type of sterilizations, this is having high penetration power. Please remember, this autoclaving process is more effective as because it is having high penetration power. The steam and the pressure can penetrate deeper inside and can cause complete clearance and killing of microorganism. And here, this steam and the pressure can cause total destructions of the surface proteins and all macromolecules present in the organisms, and as such the organisms get killed. Okay. Whereas in the ultraviolet and the gamma radiation can destroy all surface components of biological material. And ultraviolet radiation, mostly they can cause damage to the DNA material of the organisms, and organisms subsequently get killed. So these are some of the physical method of sterilization. Now, the third method, what I say is the sterilization by filtration. Why this concept has come is because in isolation process of viruses, in the isolation process of certain bacteria, we use some nutrient which are heat labile. We use some nutrients which are heat labile, means they cannot withstand high temperature of autoclaving. They cannot withstand 121 degrees centigrade. For example, we use serum agar. We add the serum to the agar media, and some of the fastidious bacteria, they love it, and some of the fastidious organisms, they need additional vitamins. Sometimes they need cholesterol, some organism. So these are some of the things that we cannot sterilize by applying heat. Once you heat it, then they will get destroyed. Think about some antibiotic solution. Suppose you want to make a antibiotic solution free of organism. You cannot heat up. Once you heat up, the antibiotic will denature and it will not retain its biological activity. So for those heat labile substances, for example, serum, for example, some of the growth factors, some example like cholesterols, or maybe antibiotic solution, we cannot sterilize by applying heat. We cannot autoclave them. So only alternative is that we can pass the solution through certain filters, so that the filter will not allow the microorganism to pass through it. So as such, we need some filters which are having very, very small pore size. They are filters, but having extremely small pore size. Or more particularly, we can say the filters which are having size lesser than that of the smallest bacteria and the fungi. So we can get rid of those environmental bacteria and the fungi get contaminated during preparation by filtration technique. So as all of you are accustomed with the filtration, everybody understands, like the water passes through certain very small pores and they can trap the organisms, and the filtered water is free of this organism. So this technique has been applied in microbiology since it's a long time. And then initially, we don't have a good quality filters. Some of the filters like sintered glass filters, number one to swing it here. These are some powdered glass powders. Some glass powder prepared from high quality glass material, and they are compressed to give a structure or shape of a filter, and the water can passes through this filter, sintered glass filters. And since their pores are very, very small, they can trap the organisms, and the filtered media and the fluids will be free of organisms. And we start calling it as we have sterilized it. But question arises, can they filter the viruses? So obviously those sintered glass filter cannot filter the viruses, so they can very well pass through it. But one of the biggest disadvantages of this sintered glass filter are that it is very difficult to reuse it. Every time if you use it, you have to go through a long process to reuse it, and it becomes costlier also. Thereafter, another type of filter, what we call the Berg-Fill or Mandler filters, which are made up of diatomaceous earth. Just like the filter candles that we use it in our household filters, but some high quality earthen filter candles were initially used for preparation of bacteriological media, but these are of not much use at the time. Then again, the porcelain, unglazed porcelain filters were also tried, but all these types are having a lot of disadvantages. Then it comes about asbestos filter pad. It's called as the SEATs. SEAT is a SEATs filter, and this particular filter pad were extensively used in 60s, 70s, 80s, up to 80s, I guess. And these are some asbestos pad filters which can very well trap and give a surety that the filtrate will be free of bacteria or fungi. But there are certain disadvantages that's found in this SEATs filter. As these are made up of asbestos material, the filtrate contains some micro traces of asbestos which become toxic and the downstream applications for virus isolation or cell culture, etc. So from 80s onward, we start using more improvised, and it is the most widely used filter nowadays. These are called as the membrane filters. Membrane filters are certain chemical filters. They are filters, but made out of certain chemicals like nitrocellulose, cellulose acetate, even some of the synthetic nylon fibers filters are also available nowadays. So all these are called as the membrane filters because it looks like a membrane, just like a membrane paper, but they're having some uniform pore size, and you can prepare different grade of filters. For example, you can have a filter of say 0.45 micrometer, you can have a filter of 0.2 micrometer, etc. Even 0.03 micrometer size filters are also available for filtration of viruses, even viruses. So these membrane filters are most commonly used filters nowadays. Okay. Now again, I'm repeating why we need the filtration techniques. Filtration techniques are applied for all those medias and chemicals where we cannot apply heat. Means we cannot hit them. They are heat labile. They will destroy if you hit them. So physical method of filtration is the only alternative for distillation. This picture is showing some of this membrane filter. These are look like ordinary paper, but these are chemical papers, not ordinary paper. And these are filters. They're having certain micro pores, and this pore can trap it. So these filters are adapted to certain devices. This is one device you can see here. 34 student has joined. I don't know why this is a fate. Okay, this is a device, what we call as the filtration device. Okay, it's having an upper part and the lower chamber, and then the lower chamber. Basically, it is an Erlenmeyer flux with the side nodes, and this side nodes is for assistance of filtration, which is usually attached to a vacuum pump. I'll show you some videos also on this regard. In the upper chamber, we just put a filter paper somewhere here. This is the filter paper, and an enlarged view is showing it here. Like this is the upper part, the solution containing this organism. When you try to pass through this filter paper, depending on the pore size, usually this filter's size is smaller than that of the smallest bacteria. Say, as I said, 0.45 or 0.22 micrometer size. So the bacteria, they cannot pass through it. They remain outside, and the water phase will come out, and the nutrients can pass through it, and this filtrates will be free of those organisms. So this is a schematic diagram showing how the filtrations work. Now, thing is that this is another device, ready-made device, filtration device. It's containing a membrane filter here, upper and lower chamber. If you assemble it, then the whole items you have to sterilize by autoclaving, and then the sterile item we can use it for filtration. Then you can remove the upper lid and pour the media that you have prepared it, containing the heat labile chemicals. But since these pore size are very, very small, so if you do not go for any assistance of vacuum pump, what will happen? The filtration rate will be very slow. You can see the drop by drop, it will pass through this membrane filter, and to filter around 100 to 200 ml of media, it may consume 7-8 hours time. So that is again not a wise thing to do. During that process, the contamination may occur. So to assist this process of filtration, a vacuum pump is attached to the lower chamber, and we suck out the air from this particular chamber. When you make the vacuum in this chamber, the atmospheric pressure will push the material, and the filtration will be very rapid. That is why we call it as a membrane filter assembly. This is very commonly we use it on the regular basis. We use it in virology laboratory, where we prepare the media and chemicals for cell culture and isolation of virus. So this assembly is extensively used. So this is called as the membrane filter assembly. Now this membrane filter assembly are suited for higher volumes, say 100, 200, 500, 1 liter chemicals or the media we can sterilize by this membrane filter assembly. If suppose your amount of the media is very less, say 1 ml, 2 ml, then this kind of a bigger apparatus is not suitable. So for that, a special item has been designed. It's called as the syringe filter. This syringe filters nowadays, most commonly we use it for filtration of low volume of media and chemicals. It is called as a syringe filter. Why? Because it can be attached to a syringe. You can draw the media and chemical in a syringe, and then you can fit, instead of the needle, you can fit this sterilized membrane filter, what we call as the syringe filter, and then you push the plunger, the media will pass through it, the filtrate will be free of organism. It can be collected in a sterile container in a sterile environment. So this is what we call as the syringe filter. Very commonly we use it in our practical class. These demonstrations will give you. It's called as the syringe filter because it is attached to a syringe and can be used it for low volume of media chemical. So these syringe filters are never used for a higher volume. So only the ml, like few mLs, 5 ml, 6 ml, 1 ml, 2 ml media chemicals we sterilize by syringe filter. If the amount is more, we go for the membrane filter assembly. Okay, this syringe filter at the center, they are having a membrane filter. As we say, this type of membrane filters, which are made up of certain chemicals like cellulose acetate or nitrocellulose or PVDF membrane filters. Even the nylon threads filters are also available, synthetic filter. So this is about this physical method of sterilization. So I just prepared one small video in our lab. Let us see. So this is sorry, I did. Okay, this is a ready-made membrane filter assembly. It's having an upper chamber and the lower chamber, and here you can see the square size membrane filter attached it here. Okay, we have the side nose and we have the vacuum pump standby. So we just pour some amount of media to the upper chamber. Okay, this video just now we have clipped it in our lab. Then the lower chamber must be sterile. Remember, these are some ready-made filtration assembly. So if you just wait it, then what will happen? The water will, the media will not get filtered. It will take a long time, drop by drop, the filtration will occur, and then you have to wait it for a longer duration. So to assist it, all the membrane filter assembly are attached with the side nose, which can be fitted to a vacuum pump. Now I'm just fitting it to the vacuum pump, and then this is a suction pump. It's a switch on the suction pump. You can see the filtration rate. Can you see here? So very rapidly filtrations means the water is passing through this membrane. So this water is now, this media is totally free of all type of bacteria and the fungi. Okay. Just switch off it. The pressure is again cleaning. If I don't use this suction pump, then it would have been taken longer time, say a few hours to complete the filtration. But here within few minutes, say like within 1 to 2 minutes, we can filter it. So this type of membrane filters are used for filtration purpose. Once the filtration is complete, we have to open it up. This part is not showing it here. We have to open up this whole device near a flame in aluminum flow. And we can put the cap and we can sterilize this item. So this way we sterilize the serum that we use it for biological work. Okay. Now what happened, sometimes in some occasion, this kind of suction pump may not be available with you. So in that case, we had another device where we use a hand suction pump. This is a hand suction pump. And then this hand suction pump can also be used, but it is not very much effective as compared to the suction pump. So we can just go on plunging it, and the air will pass out of this chamber, and gradually you can see the filtration rate is very slow. But if you don't have any suction pump or there is no current, then we can go for this kind of hand suction pump for filtration purpose. Okay, this is another. I guess I prepared it up to this part, and then lastly, what I say about this These are the techniques very commonly that we use it. The chemical methods are not very much used, but mostly we use it for disinfection purpose. For example, we use this alcohol solution, 70% ethanol, for disinfecting our hand, cleaning out the work surface before any bacterial isolation purpose, or cleaning of glass slides that we do it. And then some chemicals like phenolic compounds, we use it for disinfecting the floors and the workbenches. Then sometimes we use the fumigation chemical method. There are certain chemicals, very toxic chemicals like formaldehyde. The formaldehyde, we use it to produce fumes, what we call the process as fumigation. Fumigation is again in the process of disinfection. It cannot ascertain total 100% removal of spores, but the vegetative bacteria can be inactivated, can be killed from a room, from a small area surfaces, or maybe inside the incubator by fumigation process. It is a chemical method of disinfection. And there we use formaldehyde, glutaraldehyde, etc. These are certain toxic gases that can be used for sterilization purpose. So chemical methods are mostly used for disinfection, but physical method, most of the physical methods are meant for sterilization. So there, the dry heat, moist heat, then gamma irradiations are the absolute method of sterilization. Means they can ascertain complete removal of organism. So I'm preparing the class up to this part only. From the next class onward, we'll go for